The Azure Administrator exam, AZ-104, asks one question over and over in 100 costumes. Who is allowed to do what, and at which layer of Azure? Hold on to that sentence. It turns a sprawling syllabus into one map. The exam itself measures 5 areas. Identities and governance carries 20 to 25% of the marks. Storage carries 15 to 20. Compute is another 20 to 25. Virtual networking, 15 to 20. Monitoring and maintenance covers the last 10 to 15. 700 points out of 1,000 passes. This video is the first of 3. It takes the 2 domains at the top of the list, identity and governance, then storage. Together, they are more than 1/3 of the exam, and they are the foundation the other videos stand on. Part 2 covers compute. Part 3 covers networking, monitoring, and backup. The plan for this hour is simple. First, the shape of Azure itself, the hierarchy that every other topic hangs from. Then who you are in Azure and what you are allowed to touch. Then governance, the rules that hold even when you have permission. And finally storage, where we follow your data all the way down to a single blob. Start with the shape. Everything in Azure lives on one tree, and the exam assumes you can walk it in your sleep. At the top sits the tenant, your organization's instance of Microsoft Entra ID. The tenant is where identities live, users, groups, applications. It is not where resources live. Below the tenant come management groups, which are folders for organizing subscriptions. You might have one for production, one for development, one per department. Below management groups sit subscriptions. A subscription is a billing boundary and an access boundary. Every resource you create is paid for and governed through exactly one subscription. Inside a subscription, resources are gathered into resource groups. A resource group is a logical container for things that share a lifecycle, deployed together, deleted together. And at the bottom, the resources themselves, a virtual machine, a storage account, a virtual network. Walk it once with a concrete example. Contosa's tenant holds a management group called Production, which holds a subscription for the retail division, which holds a resource group for the web shop, which holds the shop's virtual machines and storage. Here is why this tree matters more than any single fact in this video. Permissions, policies, locks, and tags all attach to a node on this tree, and most of them flow downward. Grant a role at the subscription, and it applies to every resource group and resource inside. Assign a policy at a management group, and every subscription under it inherits the rule. When an exam question asks where to apply something, it is really asking you to pick a node on this tree. Pick the highest node that covers what you need and nothing more. One more piece of shape before we meet any users. Azure has 2 planes, and they answer to different doors. The control plane is how you manage resources. Create a storage account, resize a virtual machine, delete a network. Every one of those requests, whether it comes from the portal, the command line, or a template, goes through a single front door called Azure Resource Manager, ARM for short. ARM checks your permissions, checks policy, and then makes the change. The data plane is how you use the resource. Reading a blob out of storage, querying a database, logging into a virtual machine. Those requests go to the resource itself, at its own endpoint, and ARM never sees them. Why should you care? Because access to one plane does not automatically mean access to the other. You can be allowed to manage a storage account, even delete it, without being allowed to read a single byte of data inside it. The reverse is true too. The exam loves this seam. When we get to role definitions, you will see it written down as 2 separate lists, actions for the control plane and data actions for the data plane. And when we reach storage security at the end of this video, the whole chapter is really about who guards the data plane door. Keep the 2 doors in mind. Managing a thing and using a thing are separate privileges in Azure. Now the people. Every identity in your organization lives in the tenant in Microsoft Entra ID. A user account comes into existence in one of 2 ways. Cloud-only users are created directly in Entra, one at a time in the portal, or in bulk by uploading a CSV file, or from the command line with AZ-add-user-create. Synced users start life in an on-premises Active Directory and are copied up to the cloud by a sync agent, so the company's existing accounts appear in Entra automatically. On the exam, the tel is the source column on the user list. Cloud-only accounts say Microsoft Entra ID, synced ones say Windows Server AD, and synced accounts are managed at the source, so you change their properties on-premises, not in the cloud. Every user has a user principal name, which looks like an email address and has to use one of the tenant's verified domains. A few properties matter more than they look. Usage location, for one. It seems like trivia, a two-letter country code on the user object. But assigning a license directly to a user fails without it, because Microsoft has to know which services are legal to offer in that country. Questions about a license that will not assign are often really questions about a missing usage location. And deletion is gentler than it sounds. A deleted user sits in a recycle bin for 30 days and can be restored with everything intact. Users are managed in bulk through groups, and Entra has two axes you can mix. The first axis is group type. Security groups exist to control access. You point role assignments, app access, and licenses at them. Microsoft 365 groups add a shared mailbox, calendar, and files for collaboration. For an administration exam, security groups do most of the work. The second axis is how members get in. With assigned membership, an owner adds and removes each member by hand. With dynamic membership, you write a rule against user properties, something like user department equals finance, and Entra evaluates it continuously. Anyone whose department changes to finance joins on their own. Anyone who moves on falls out on their own. There is a processing delay while the rule engine catches up, so a fresh property change does not move someone instantly. Dynamic rules can target users or devices, but one group cannot mix both. Dynamic membership needs a Microsoft Entra ID P1 license, and that is a fact the exam checks. Groups also distinguish owners from members. Owners manage the group itself, its membership and its settings, without needing any directory admin role. Members simply receive whatever the group grants. Groups can also nest, though several features, licensing among them. Only honor direct members. One more habit worth building now. Whenever you catch yourself granting anything to an individual user, a role, a license, an app, stop and ask whether a group should hold it instead. Nearly every messy access story in a real tenant starts with grants scattered across individuals. Licenses decide which Microsoft services a user can actually use, and there are two ways to hand them out. Direct assignment attaches a license to one user at a time. It works, and it does not scale. Group-based licensing attaches the license to a security group, and every member inherits it. Join the group, get the license. Leave the group, and the license is removed automatically. That automatic removal is the selling point and the exam answer. Licensing follows membership, so onboarding and offboarding stop being manual chores. Within a license, you can also switch individual service plans off, keeping the mail plan while disabling a service the department does not use. Two details to remember. Direct assignment demands a usage location on the user, as we said. Group-based licensing is more forgiving. A member with no usage location inherits the tenant's default location instead of failing. And group-based licensing is a premium feature, so the tenant needs the appropriate paid Entra license. When an assignment fails anyway, say the tenant ran out of seats, Entra records the user in an error state rather than silently skipping them, and the group's licensing page shows exactly who is affected. The rhythm to keep. Groups carry licenses, membership drives everything, and usage location is the quiet prerequisite. Not everyone who needs access works for you. A consultant with a Gmail address, a partner company's engineer. Entra handles them through B2B collaboration, business to business. You invite the external person by email. They redeem the invitation using their own credentials, their own identity provider, their own password that you never see or store. What appears in your tenant is a guest user object, a real directory entry, marked with user type guest that you can put into groups and grant roles exactly like an employee. The point of the design is that you manage their access without managing their identity. Tenant-wide external collaboration settings decide who may invite guests in the first place and how much of the directory a guest can even see once inside. When the engagement ends, you delete the guest object or let an access review clean it up, and their account at home is untouched. On the exam, external collaborator scenarios almost always resolve to inviting a guest, not creating a new member account with a password. Last stop in identity, passwords, and what happens when someone forgets one. Self-service password reset, SSBR, lets users reset their own password after proving who they are, instead of opening a help desk ticket. You enable it in one of three modes: none, selected, or all. Selected scopes it to a single group, which is how organizations pilot the feature with one department before turning it on everywhere. Before a user can reset anything, they must register verification methods, a notification or code from an authenticator app, an email address, a phone call or text, or security questions, and registration is usually combined with multi-factor sign-up, so users only go through it once. Policy decides how many methods they must register and how many they must present at reset time. Requiring 2 methods to reset is the common, safer configuration. One asymmetry to remember for the exam: administrator accounts do not follow the policy you configure. Microsoft enforces a separate, stricter reset policy for privileged roles automatically. Always 2 methods, and security questions are never allowed for them. It makes sense when you think about it. The account that can reset everyone else deserves the strongest gate. That closes out identity. In one breath each, users are cloud-only or synced, groups carry access and can fill themselves dynamically. Licenses ride on groups and need a usage location. Guests are invited identities you govern but do not own, and SSBR gives passwords back to their owners with a stricter path for admins. Identity says who you are. Azure Role-Based Access Control, RBAC, says what you may do. And every RBAC decision, without exception, is built from the same 3 parts. Part 1, a security principle, the who, a user, a group, a service principal that an application signs in with, or a managed identity that Azure itself operates for a resource. Part 2, a role definition, the what, a named list of permitted operations, like reader or contributor. Part 3, a scope, the where, a node on the hierarchy from earlier, a management group, a subscription, a resource group, or a single resource. Bind the 3 together, and you have a role assignment. That is the entire model. This engineer may do contributor things in this resource group. When an exam question about access looks complicated, and they often do, decompose it into the triangle. Who is the principal? Which role? At what scope? The wrong answers usually get exactly 1 corner wrong, a role that is too broad or a scope 1 level too high. Find the corner that is off, and the question collapses. Azure ships hundreds of built-in roles, but 4 general ones do most of the exam's work. Reader can look at everything in scope and change nothing. Contributor can create, change, and delete resources, but cannot touch access itself. No granting roles, no removing them. Owner is contributor plus exactly that missing power, managing access for others. And user access administrator is the strange one. It can manage who has access without being able to manage any resources. A newer sibling, role-based access control administrator, grants roles and nothing else, and it is the recommended way to delegate access management with less blast radius than owner. Now look under the hood, because the exam does. A role definition is a small JSON document. Its actions list names the control plane operations the role permits, with wildcards, so contributor starts with a star, everything, and then subtracts. Its not actions list carves out the exceptions, and for contributor those exceptions are precisely the authorization operations, which is why it cannot grant access. Remember the 2 planes from the start of the video? Role definitions honor the seam. Control plane permissions live in actions. Data plane permissions live in a separate list. Data actions and roles like storage, blob data, reader grant only those. Owner of a storage account with no data role can still be refused a blob read. When a question hinges on someone with a grand-sounding role being denied something, check which plane the operation lives on before anything else. The third corner of the triangle, scope, is where the hierarchy earns its keep. You can assign a role at a management group, a subscription, a resource group, or one resource, and the assignment flows downward through everything underneath. Reader on a management group means reader on every subscription below it, every resource group inside those, every resource inside those. There is no way to block the flow on a branch. Inheritance in RBAC has no exceptions, so the only lever you have is choosing the right node in the first place. The standing advice, and the exam's favorite correct answer, is least privilege, the narrowest role at the lowest scope that still covers the need. Access for one application's resources belongs on that resource group, not on the subscription. The second rule, assignments are additive. If one assignment gives you reader on the subscription and another gives you contributor on a resource group inside it, you hold both, and inside that group the union applies, so you can write there and merely read elsewhere. There is no assignment that subtracts. With one rare exception we will meet in a moment, nothing you grant ever takes a permission away. And when no built-in role fits, you clone the closest one into a custom role, the same JSON shape, your own list of actions, plus assignable scopes that say where the role is even allowed to appear. The exam mostly wants you to know custom roles exist, live in the tenant, and can be shared across subscriptions through those assignable scopes. The exam will show you an access screen and ask what a person can actually do, so let us learn to read one. The role assignments view lists principal, role, and scope, one row each. 2 details trip people. First, scope written as this resource says inherited from where the assignment actually lives. A contributor row inherited from the subscription cannot be removed by fiddling with the resource. You have to go up to where it was granted. Second, group membership counts. If Maria appears nowhere but a group she belongs to holds contributor, Maria effectively holds contributor, and the check access tool on the same screen will do that arithmetic for you, which makes it the fastest honest answer to what can this person do here. Now that rare exception, deny assignments. A deny assignment explicitly blocks an operation even when a role grants it, and you cannot create one yourself. Azure creates them, for example, when a deployment stack protects the resources it manages. If a question describes an owner who mysteriously cannot delete something and the answer choices mention deny assignments, that is the mechanism. Last distinction, and it is a classic, Entra directory roles and Azure RBAC roles are different systems. Global administrator rules the directory, users, groups, licenses, and holds no power over subscriptions by default. There is a deliberate bridge. A global administrator can flip a switch. The portal calls it Elevate Access to gain user access administrator over every subscription in the tenant, meant for recovering orphan ones. Directory power and resource power are separate until someone explicitly bridges them. REAC has a blind spot. It decides who can act, but it says nothing about what they build. A contributor can create a virtual machine, and RBAC is equally happy whether that machine is a small burstable instance in your home region or a giant GPU box on the other side of the world with a public IP hanging off it. Azure Policy is the system that fills the gap. Policy does not care who you are. It inspects the resource itself, what type it is, where it is, how it is configured, and passes judgment against rules you set. The two work in tandem. RBAC lets Maria create virtual machines in the resource group, and Policy quietly adds, as long as they are in West Europe and carry a cost center tag. The two systems are complementary, and the exam tests the boundary directly. Who can create resources in this group? That is RBAC. All resources must live in West Europe, or every deployment must carry a cost center tag, or nobody may create public IP addresses at all. That is Policy. Permission and compliance. One guards the door, the other inspects what comes through it. Policy has 3 moving parts, and they slot into the tree you already know. A policy definition is one rule written in JSON, a condition to match, say, resource location is not in an approved list, and an effect to apply when it matches. Definitions take parameters, so one definition, allowed locations, can be reused with different lists in different places. An initiative, formerly a policy set definition, bundles related definitions into one package. Real compliance regimes are dozens of rules. Assigning them one at a time is misery, so you group them and assign the group. Which brings us to the assignment, a definition or initiative attached to a scope, a management group, a subscription, or a resource group, with its parameters filled in. Assignments inherit downward exactly like role assignments do, and an assignment can carve out exclusions, so you can bind a rule to the whole subscription except the sandbox resource group where experiments are allowed. Definition, initiative, assignment. Rule, bundle, binding. What actually happens when a resource meets a policy comes down to the effect, and effects are where exam questions live. Audit is the observer. The resource deploys anyway, and the policy records it as non-compliant for the reports. Deny is the wall. The deployment fails outright with a policy error. Append and modify are the editors. They change the request on its way through, appending required settings or modifying properties, which is how a mandatory tag gets stamped onto everything at creation. Deploy if not exists is the fixer. After a resource deploys, if some companion configuration is missing, the policy deploys it, and audit if not exists is its observer twin that only reports the gap. And disabled simply switches a definition off. When does evaluation run? At creation and update, when a request passes through Azure Resource Manager on its way in. And on a periodic compliance cycle, roughly daily, that sweeps existing resources. That second path matters. Assigning a new policy to an old subscription does not delete anything that already exists. Existing offenders are marked non-compliant, not destroyed. Deny stops the future. It cannot rewrite the past. And evaluation is not instant either way. After a deployment, expect the compliance record to appear within about 15 minutes, and after a brand new assignment, allow up to half an hour before results are trustworthy. So, what do you do about the past? The compliance view shows every assignment with what it found, resource by resource, and for the effects that can fix things, there are remediation tasks. A remediation task tells a deploy if not exists or modify policy to go back over existing non-compliant resources and apply its change now, instead of waiting for each resource's next deployment. One requirement the exam likes. Remediation runs as a managed identity, an identity the policy assignment owns, and that identity needs the right role on the target scope to make its changes. No identity or no permission, and remediation quietly does nothing. Quick recap of governance so far. A policy definition is one rule, an initiative bundles rules, an assignment binds them to a scope with inheritance. Effects run from audit, which only reports, through deny, which blocks, to deploy if not exists, and modify, which repair, and remediation tasks apply those repairs backward to what already exists. Sometimes the danger is not a rogue user, but a well-meaning one, and for that Azure has resource locks. A lock attaches to a subscription, a resource group, or a resource, and comes in two strengths. Cannot delete allows reading and modifying, but blocks deletion. Read-only is harsher. Nothing but reads. Everyone, including owners, is bound by a lock because locks are checked after RBAC as a separate gate. To delete a locked resource, you must first delete the lock, and that extra deliberate step is the entire point. Locks inherit downward, so a lock on a resource group covers everything inside it, including resources added later, and when two locks overlap, the more restrictive one wins. One boundary to keep straight. Locks guard the control plane only. A read-only lock on a storage account does not stop anyone reading or writing blobs inside it. It stops changes to the account resource itself. Now, the gotcha the exam loves. Read-only means only read operations reach the resource, and some operations you think of as reads are technically writes or posts under the hood. The classic is listing storage account keys. It is a post request, so a read-only lock on a storage account locks it, and suddenly applications that fetch keys start failing even though nobody touched the data. When a question describes mysterious failures after someone added protection, suspect a read-only lock doing exactly what it was told. Tags are the labeling system. Name and value pairs you stick on resources, resource groups, and subscriptions. Environment production. Cost center 4217. Owner, the platform team. They exist because your subscription will eventually hold thousands of resources, and questions like which department is spending this money have to be answerable by machine. Cost reports can group and filter by tag, which is why the finance-flavored questions on the exam almost always end in tags. 2 mechanics to lock in. First, tags do not inherit. Tagging a resource group does nothing to the resources inside it. Each resource carries its own tags. Any question implying resources inherited a tag from their group is testing exactly this. If you want inheritance, you build it with the previous chapter's tool. An Azure Policy with a modify effect can copy a tag from the group onto every resource, or deny anything created without a required tag. Second, the limits. 50 tag pairs per resource, resource group, or subscription. Names are case-insensitive and management groups cannot be tagged at all. Applying them is one line either way. AZ tag create from the CLI or the tags blade in the portal. Tags plus policy is the pattern to remember. Tags hold the metadata. Policy makes the metadata trustworthy. Resource groups themselves have management chores the exam checks directly. A group is created with a name and a region, and that region only says where the group's metadata lives. A group in West Europe can happily hold virtual machines in East US. Deleting a group deletes every resource inside it, in one irreversible sweep, which is both the feature, clean teardown of an environment, and the hazard the locks from 2 scenes ago exist to prevent. Groups cannot nest, and every resource belongs to exactly one group at a time. But membership is not a life sentence. Resources can move to another resource group or to another subscription with AZ Resource Move or the Move button in the portal. 3 fine points travel with that move. The resource IDs change, so anything hard-coding the old path breaks. Both the source and destination groups are locked against writes while the move runs. And not every resource type supports moving, so Azure offers a validate call that checks the whole move before anything actually happens. Running that validation first is a professional answer when a question asks how to move safely. Moving a resource between groups never moves it between regions. Relocation to another region is a different, heavier operation. Climb to the top of the tree for a moment. Management groups organize subscriptions, and one directory can hold up to 10,000 of them, arranged up to 6 levels deep, not counting the root at the top or the subscriptions at the bottom. Every directory has that root management group, and every subscription hangs somewhere under it. The payoff is single-point governance. Assign a policy or a role once at a management group, and every subscription below inherits it, which is exactly how you enforce a rule across 40 production subscriptions without repeating yourself 40 times. Moving a subscription between management groups needs write permissions on both sides, and the move has consequences. The subscription immediately sheds the old parent's inherited policies and roles and picks up the new parents. That is the detail exam scenarios poke at. What changes the moment the subscription lands in its new home? Subscriptions themselves can also be renamed, transferred to other billing owners, or canceled, but for the exam the geometry is the point. Management groups above, subscriptions below, governance flowing down. Governance also means governing money. Microsoft Cost Management, built into the portal, has an analysis view that slices actual spend by subscription, resource group, service, or tag, and it is where those cost center tags pay off. For control, you create budgets. A budget sets an amount and a period, and alert thresholds. Notify these people at 80%, again at 100, and you can even alert on forecasted spend before it happens. Here is the sentence the exam wants you to know cold. A budget never stops spending. It sends notifications. It does not switch anything off. Azure will happily bill you straight through a blown budget, and answer choices claiming a budget shuts down resources are wrong. If you genuinely want automation, A budget can trigger an action group, and the automation you attach does the stopping. The budget itself only speaks. The third character in the money story is Azure Advisor, a free recommendation engine that continuously reviews your resources across 5 categories: cost, security, reliability, operational excellence, and performance. On the cost side, it spots idle virtual machines, unattached disks, and underused capacity you could shrink. Recap of the governance toolkit in one breath: lock stop accidents, tags label for organization and billing, resource groups bundle life cycles and let resources move with validation, management groups spread governance across subscriptions, budgets warn about money without stopping it, and advisor suggests improvements you did not ask for. Now, we follow the data. Everything Azure stores for you lives inside a storage account, and one account is really 4 services, wearing one name tag. Blob storage holds objects, files, images, backups, anything unstructured. Azure Files holds real file shares you can mount like a network drive. Queue storage holds messages passing between application components. And table storage holds simple NoSQL rows. One account, one bill, one security boundary around all 4. When you create an account, you make 2 choices that cannot be easily unmade. Performance. Standard accounts run on hard drives and premium accounts run on SSDs with much lower latency. And kind. The workhorse is General Purpose v2, which supports all 4 services and every redundancy option, and it is the right answer unless a question begs for something special. The premium kinds are specialists. One for block blobs when latency is everything, one for file shares that need SSD speed, one for page blobs, the disks we will meet again under virtual machines in Part 2. Each trades flexibility for speed. The exam default is simple, General Purpose v2 unless stated otherwise. Every byte you give Azure is copied, and the redundancy setting decides how far the copies spread. This is the most examinable table in the storage domain, so let us build it. Locally redundant storage, LRS, keeps 3 copies in a single data center. It survives a dead drive or a dead rack. It does not survive the data center flooding. Zone redundant storage, ZRS, spreads copies synchronously across separate availability zones, separate buildings with separate power and cooling in the same region. A write is only acknowledged once every zone has it. Now a whole facility can burn down and your data is fine. Geo-redundant storage, GRS, takes LRS and adds a second act. 3 more copies in a paired region hundreds of miles away, 6 in total. And unlike the zone copies, the geo copies are asynchronous, trailing the primary by however long replication takes. Geo-zone redundant storage, GZRS, is the top shelf. Zone redundant at home, plus that distant second region. Both geo flavors have a read access variant, RA-GZRS and RA-GZRS, which lets your applications read from the secondary region at any time at a separate endpoint with -secondary in the name. The latter is really 3 questions. Does a rack failure hurt you? LRS handles that. A zone failure? ZRS. A regional disaster? You need geo. And do you want to read from the far copy without waiting for a disaster to be declared? That is the RA on the front. So the region burns down. What actually happens? The copies in the secondary region are asynchronous, which means they run a little behind the primary. Every geo-redundant account publishes a last sync time. Everything written before that moment is safely in both regions, and anything after it might exist only in the primary. That gap is your potential data loss, and reading last sync time correctly is a legitimate exam skill. If the primary becomes unavailable, you can start a customer-initiated failover. The secondary region is promoted to primary, DNS is updated, and your applications carry on against the same account name. 2 consequences to remember. First, writes that had not replicated are gone. Second, after an unplanned failover, the account wakes up as plain LRS in its new home region. The disaster spent your geo-redundancy, and you have to re-enable it deliberately to get a new secondary. There is also a planned flavor of failover, run while both regions are healthy, for drills or region moves. It keeps your geo-redundancy because the regions can synchronize fully before swapping roles. But the unplanned kind is a break-glass move, not a routine one. A few practicalities before we dive inside the account. Names first. A storage account name is 3 to 24 characters, lowercase letters and numbers only, and globally unique across all of Azure because the name becomes a public DNS address. Each service gets its own endpoint carved from it. The Blob service answers at the account named Blob, Cord, Windows, Net, Files at .file, queues, and tables likewise. Creating an account from the command line is one line. AZ Storage account create, with a resource group, a location, a SKU like standard_GRS, and a kind, storage v2. Notice the SKU strings bundle performance and redundancy together, standard LRS, premium LRS, standard GZRS, so the choices from the last two scenes travel as one setting. And redundancy is not a life sentence. Some conversions, like LRS up to GRS, are a settings change that starts replicating to the partner region. Moving into or out of zone redundancy is heavier, a conversion you initiate that runs in the background, with no completion promise, and you wait days between successive changes. One interaction worth filing away. An account holding archive tier blobs cannot convert to zone redundancy until those blobs are rehydrated. The account is the shell. Next we go inside to blobs. Inside the blob service, the structure is shallow on purpose. An account holds containers and containers hold blobs. That is the whole tree. The folders you see in tooling are a courtesy. Blob names can contain slashes, so report /2026/January. CSV looks nested, but the namespace is actually flat and the name is just long. Blobs themselves come in 3 kinds, and the exam expects you to match kind to job. Block blobs are the default and the workhorse, a file uploaded as a set of blocks, ideal for documents, images, video, backups. Append blobs only grow at the end, which makes them right for logs, where you add lines and never rewrite old ones. Page blobs support random reads and writes in place, and they exist mainly as the disks behind virtual machines. Nearly every question that just says files or objects means block blobs. Containers also carry a public access setting, and the modern default is that anonymous access is disabled at the account level, so nothing is readable without credentials unless someone deliberately opens it. Not all data earns its keep equally, and blob access tiers price that honestly. The hot tier is for data you touch often, the highest price to store each gigabyte, the lowest price to read it. Cool flips the trade for data you touch rarely, cheaper to hold, more expensive to access, and it expects blobs to stay put for 30 days. Cold pushes further, 90 days. And archive is the deep freeze. Storage for a fraction of a cent, but the blob goes offline. You cannot read an archived blob at all until you rehydrate it back to an online tier, and rehydration is slow, up to 15 hours at standard priority for blobs under 10 gigabytes. Paying for high priority can shrink that to under an hour for the same sizes. Tiering applies to block blobs, and while the account sets a default tier for new uploads, the setting is per blob in the end, changed with the set tier operation. So one container happily mixes hot files next to archived ones. One more mechanic rounds out the picture. Each tier has an early deletion clock, 30, 90, and 180 days for cool, cold, and archive. Delete or move the blob sooner, and you pay the remainder anyway. The pattern to internalize. Pick the tier that matches how often the data moves, and let the price follow. Nobody wants to re-tier a million blobs by hand, so the Blob service has lifecycle management, rules that patrol your account and act on age. A rule is a small JSON policy with a filter which blobs it watches, maybe just block blobs under one container prefix, and actions on a timer. The classic staircase reads like this. When a blob has gone 30 days without modification, move it to cool. After 90, move it to cold. After 180, archive it. After 7 years, delete it. That single rule turns an expensive hot account into a self-managing archive, and it is the exam's favorite storage automation answer. Timers can count from creation time or last modification, or even from last access if you switch on access tracking, which is the right base when old files still get read occasionally because it stops the rule from archiving something people opened yesterday. Rules can also tend previous versions and snapshots separately from current blobs, aging out old versions faster than live data. One expectation to set: the policy runs periodically in the background, and a new or changed rule can take up to a day to take effect. Lifecycle management is cost optimization on autopilot. The next scene is about surviving mistakes. 3 protection features guard blobs against human error, and the exam tests whether you know which one saves you from what. Soft delete is the recycle bin. Delete a blob and it lingers, invisible but recoverable, for a retention period you set between 1 day and a year. Container soft delete is a separate switch doing the same for whole containers. Blob versioning protects against overwrites. Every time a blob is modified, the service automatically keeps the previous version with its own ID, so you can promote an older version after a bad upload. No action needed at write time. That automatic part is what distinguishes it. Snapshots are the manual cousin, a read-only copy of a blob frozen at the moment you ask for one, useful when you want a deliberate checkpoint before a risky change. Line them up by the mistake they undo. Deleted something? Soft delete. Overwrote something? Versioning. Wanted a checkpoint on purpose? Snapshots. They stack, and in a production account you typically run soft delete and versioning together, accepting a little extra storage cost as the price of sleeping well. One last blob capability: object replication, which copies block blobs from a container in one storage account to a container in another, even across regions and subscriptions. Unlike the redundancy settings from earlier, which duplicate the whole account to a fixed partner region, object replication is surgical. You write rules mapping the source container to that destination, optionally filtered by prefix. The copy is asynchronous, so treat it as eventually consistent rather than instant. Prerequisites are the detail the exam checks. Blob versioning must be enabled on both the source and the destination account, and change feed must be enabled on the source, because the replication engine reads the change feed to know what moved. Use cases are easy to picture: keeping a copy of uploads near compute in another region, or feeding a separate analytics account without touching production. That closes the tour of blob storage. Containers and 3 blob kinds, for temperature tiers with lifecycle rules to walk data down the staircase, 3 safety nets against 3 different mistakes, and replication when copies need to cross account lines. Blob storage speaks HTTP, and plenty of software does not. A payroll application from 2012 wants a drive letter. That is the job of Azure Files. Real file shares in the cloud, mounted over standard protocols. No application changes required. The protocol of the house is SMB, the same protocol Windows file servers have spoken for decades, which is why lift and shift scenarios, moving an old app without rewriting it, are the signature use case. Linux-first workloads can use NFS shares instead, version 4.1, though those require the premium tier and stay within local or zone redundancy. On performance, standard shares run on hard drive-backed storage built by what you use, while premium shares run on SSDs with provision capacity, sized and paid for upfront, the trade being predictable speed for a predictable bill. Shares live inside the same storage account as everything else, next to the blob containers. Choose Files over Blob when something needs to mount a share, when multiple machines need the same directory, or when you are replacing an on-premises file server. Choose Blob when applications talk to storage through APIs. The exam phrases it as a workload question. The answer is really a protocol question. Mounting a share with a storage account key works, but it makes everyone who mounts it the same all-powerful user, and no auditor will love that. The grown-up alternative is identity-based access, where users authenticate as themselves. Azure Files supports 3 identity sources: on-premises Active Directory domain services, for machines joined to a classic corporate domain; Microsoft Entra domain services, a managed domain in the cloud; and Microsoft Entra Kerberos, the modern option, which issues Kerberos tickets straight from Entra for hybrid and cloud-only identities. No domain controller in the conversation. Whichever source you pick, authorization happens at 2 gates, and the 2-gate model is the exam's favorite detail here. Gate 1 is the share level, an Azure RBAC role assignment, such as storage file data SMB share contributor, decides whether you may enter the share at all. Gate 2 is the file level. Windows-style NTFS permissions on directories and files decide what you can do once inside. You need to pass both. A share-level role with no NTFS permission gets you a locked door inside the lobby. NTFS permissions without the role never get you into the lobby at all. Files has its own safety nets, tuned to the file server way of life. Share snapshots capture the whole share at a point in time, read-only, stored as just the differences, and users can browse a snapshot like a folder and copy back what they need. On Windows, it surfaces as the previous versions tab admins already know. You can take snapshots manually or on a schedule through Azure Backup, and a share can hold up to 200 of them. Soft delete, meanwhile, protects the share itself. Delete a share and it lingers, recoverable, for a retention window between 1 and 365 days. Notice the split, because a question will probe it. Snapshots protect the contents from bad edits and deletions inside the share, while soft delete protects against the share being deleted outright. Snapshots for the files, soft delete for the share. One practical wrinkle deserves its own moment. SMB travels over TCP port 445, and a large share of consumer internet providers block port 445 outright, a leftover defense from an old generation of Windows worms. From the office network, fine. From home, the mount fails and nothing tells you why. The portal's connect button generates a ready-made script for Windows, Linux, or Mac OS that maps the share to a drive letter, embeds the right credentials, and even reconnects that sign-in. When it fails anyway, test port 445 before anything else. Corporate networks and VPNs into Azure pass it. Hotel and home connections often do not. We built the account, filled it with data, and now comes the question this whole video has been circling. Who gets in? Storage has 3 ways to answer, and they form a ladder from bluntest to finest. At the bottom, the access keys. Every storage account is born with 2, and either key is total power over the account's data plane. Every container, every share, forever, until the key is rotated. There are 2, so you can rotate one while applications move to the other. Keys are the break glass credential. Necessary, dangerous, and shared by everyone who holds them, so nothing in the audit log says who did what. In the middle, shared access signatures, SAS. Signed tokens that delegate a slice of that power, this much access, to this resource, until this time. And at the top, Microsoft Entra, real identities with RBAC data roles like storage blob data reader, auditable, revocable, no secrets floating around. An account can even be configured to refuse shared key access entirely, forcing every request through Entra, and that switch is exactly what a question about eliminating stored account keys is fishing for. The guidance on the exam and in life is to live at the top of the ladder when you can and climb down only when you must. Shared access signatures deserve a closer look because the exam picks at their details. A SAS is a URL with a signed query string. Anyone holding the URL gets exactly the access described in it. No login required. What is described? The services it covers: blob, file, queue, table. The resource types, the account itself, containers or objects. The permissions: read, write, delete, list, and friends. A validity window with a start and expiry. Optionally, an allowed IP range and HTTPS only. 3 flavors exist. An account SAS is signed with an account key and can span multiple services. A service SAS is also key-signed but scoped to one resource in one service, one blob, one container. A user delegation SAS is the modern one, signed with a key derived from Microsoft Entra credentials rather than any account key, which means it survives key rotation, works where shared keys are disabled, and shows up against a real identity. Microsoft recommends it wherever possible. Now, the classic gotcha. A key-signed SAS cannot be revoked on its own. It is just math over the key. The service validates the signature and no record of the token exists to delete. Until it expires, the only way to kill it is to regenerate the key that signed it, which instantly kills every other SAS signed with that key too. Short expiry times are not politeness. They are the only leash you have. There is a way to put SAS tokens on a proper leash: stored access policies. Instead of baking permissions and expiry into the token itself, you define a named policy on the container, up to 5 per container, holding those settings server-side. Then you issue service SAS tokens that simply reference the policy by name. The token says policy A. The container decides what policy A currently means. Now revocation is civilized. Change the policy's expiry to the past or delete it, and every SAS pointing at it dies instantly. No key rotation, no collateral damage to other tokens. The trade-off is scope. Stored access policies work with service SAS only, not account SAS, not user delegation SAS. For the exam, the pairing to remember is exactly that: service SAS plus stored access policy equals revocable delegation. Credentials are one gate, the network is another. By default, a storage account answers to the whole internet, authenticated or not at the door but reachable by anyone. The storage firewall narrows that. Flip the account to selected networks, and everything is denied except what you allow. Specific virtual networks and subnets, specific public IP ranges, or specific resource instances. You can also disable public network access entirely and reach the account only through private endpoints, a private address inside your own network. Those get their full treatment in Part 3 of this series. One switch matters more than the rest on the exam. Allow trusted Microsoft services. Platform services like Azure Backup and Azure Monitor operate from outside your networks, and a strict firewall locks them out too, until that exception is on. A scenario where backups started failing right after someone hardened the storage firewall is pointing straight at it. Last layer: encryption at rest. Every storage account encrypts everything, always, with 256-bit AES, and you cannot turn it off. So the exam never asks whether data is encrypted. It asks who holds the keys. The default is Microsoft Managed Keys, zero effort, invisible. Organizations that must control their own key material switch to customer-managed keys, held in Azure Key Vault. You gain rotation on your schedule and the power to revoke, and you take on the responsibility of not losing the key. For the truly cautious, there is infrastructure encryption, which encrypts data a second time at the hardware layer with a separate key, so a compromise of one algorithm or key still leaves a locked box. It can only be chosen when the account is created. And encryption scopes let a single account hold data under different keys, per container or even per blob, which is how one account serves multiple customers who each demand their own key. Climbing down the security stack, then, identities first, SAS with stored policies when you must delegate, keys guarded and rotated, the firewall deciding which networks may even knock, and encryption underneath it all, with the only real question being who keeps the keys. 2 tools round out the storage story, one for hands and one for scripts. Azure Storage Explorer is the hands, a free desktop application for Windows, Mac OS, and Linux that browses accounts like a file manager, upload, download, edit tags, manage snapshots. It connects however you can authenticate, an Entra sign-in, an account name and key, or a SAS, which makes it the easy way to hand a colleague scoped access to one container. Generate a SAS, they attach Explorer to it. Done. AzCopy is the scripts, a command line tool built for moving data at serious scale, and it is what Storage Explorer quietly uses under the hood for transfers. 2 verbs carry the exam weight. AzCopy copy moves data from here to there, local to cloud to cloud, entire containers with a recursive flag. AzCopy sync makes the destination match the source. only transferring differences, and with the delete destination flag, it will remove files that no longer exist on the source, a true mirror. Copy adds, sync mirrors. That distinction is the question. It authenticates through AzCopy login with an Entra identity or through SAS tokens pasted into the URL, and big jobs that die halfway can resume where they stopped. Before the recap, a quick tour through the traps this domain sets, each one a scenario you will recognize on the day. Backups or monitoring broke right after someone hardened a storage firewall. The trusted Microsoft services exception is off. An owner cannot delete a resource. Look for a lock, or more rarely, a deny assignment. Applications started failing after someone added a read-only lock to a storage account. The lock is blocking the list keys operation. A license will not assign. Check the usage location. A tag on the resource group is missing from the resources inside. Tags never inherit. Use a policy with a modify effect. A budget was exceeded and resources kept running. Budgets only notify. That is the design behavior. A SAS token leaked and must die now. Regenerate the key that signed it, or if it referenced a stored access policy, just edit the policy. Data must survive a regional disaster and be readable in the second region today, that is RA-GZRS or RA-GZRS, the read access variants. An archived blob is needed this afternoon. Rehydration takes hours at standard priority. Pay for high priority or plan better. And a user in the finance group cannot enter the finance file share. They passed the share level role gate, but the NTFS gate said no, or the other way around. Every one of these is a fact from this hour, wearing a story as a disguise. Time to fold the map back up. Everything in this video hangs on one tree. Tenant at the top, then management groups, subscriptions, resource groups, resources with permissions and policies flowing downward from wherever you attach them. Identity lives in Microsoft Entra. Users cloud-only or synced, groups static or dynamic, licenses riding on groups, guests invited from outside, and self-service password reset with a stricter path for admins. REAC answers who can act. Principal, role, scope, with assignments that only ever add, and custom roles when the built-ins do not fit. Azure Policy answers what may exist. Definitions bundled into initiatives, assigned to scopes, with effects from audit through denied to deploy if not exists, and remediation for what already exists. Locks stop accidents on the control plane. Tags label for money and order, and never inherit on their own. Resource groups bundle life cycles, and resources move between them with validation first. Budgets warn without stopping anything, and advisor suggests. Then storage, an account holding blobs, files, queues, and tables, with a redundancy ladder from LRS through ZRS and GRS to GZRS, and a last sync time that measures what a disaster would cost you. Blobs come in 3 kinds and 4 temperature tiers with lifecycle rules to walk them down, plus soft delete, versioning, and snapshots for 3 different kinds of mistake. Azure Files serves SMB shares with 2-gate identity access over port 445. And the account's doors are guarded in layers. Keys at the bottom, SAS in the middle with stored policies for revocation, Entra identities at the top, a network firewall around all of it, and encryption you cannot switch off underneath. That is the first third of the exam, and honestly the third that makes the rest make sense, because every later topic will lean on this hour's vocabulary. Scopes, roles, policies, accounts, tiers. In part 2 we climb the compute ladder. ARM templates and Bicep for declaring infrastructure as documents, virtual machines with their disks, sizes, and availability story, containers and registries, instances and container apps, and app service at the top where Azure runs the platform for you. The hierarchy, the RBAC triangle, and the storage accounts from this hour keep reappearing there, holding the disks, the images, and the app files. See you in part 2.